We now need two services to be running for our application: the Quart web server and a Postgres database server to store our data. For this and all of my other courses, I will be focusing on developing locally using Docker, as this is the preferred development environment used by professional teams. If you haven't used Docker before, don't worry, just follow the instructions. I also have a Docker for Flask course if you want to learn more about Docker. So let's go ahead and set up our local Docker development environment. First, you need to download the Docker desktop client for Windows or Mac, which you can find in the Docker website. Just follow the instructions. Once you have Docker client running, you can check if it's properly installed by typing the following on your terminal. If you see a welcome message, everything is good to go. Let's start by creating our Docker file. First, create the directory where the application will live. You can create this directory inside your user's home directory. If you plan to use a directory outside of your personal folder and you are a Mac user, you will need to add it to the Docker client file sharing resources on Preferences. So I'll call mine counter app. So I will do make dir counter app. Now cd into your application folder and open a code editor to create the Docker file. It looks like this. First, we define the base image as an Ubuntu 20.04 image. Next, we install all the Ubuntu packages we will need. We'll also turn off the disruptive pip version check prompts. Next, we install Poetry using pip3. We then create the counter app directory in the Docker instance and set it as the default location for the code. At this point, we need to set up Poetry, so we copy the PyProject TOML file to prepare the install. We then set some flags for Poetry to work best and install all the packages. Right after that, we copy the contents of the local directory into the counter app directory using the copy command. Once all the code is in place, we open the 5000 port and invoke the Poetry run command. Save the file. Now we need to create a Docker Compose file that will build up both our application instance as well as a Postgres instance. We will create the services using the following dockercompose.yaml file. First, we describe the Docker Compose file version as 2. We then start defining the services, which are essentially the containers that will be running at the same time. The first service is the web application, which we are calling web. We instruct Docker Compose to build a container using the Docker file in the same directory using the build dot statement. Next, we open up port 5000 both in the host as well as in the container, as this will be the port that Quart is assigned to listen on. Then we mount the current host's Windows or Mac computer directory as a volume inside the container, which will be mounted as counter app. This will allow us to code on the host machine and propagate those changes in the container instantly. The links statement describes that this container is connected to another service, which we will call DB, but inside the container it will be reachable as Postgres. We then assign the name of the container to be app-web1 and instruct Docker Compose that it depends on the DB service to be up. The next two statements, standard in open and tty, are added so that we can execute the Python debugger and examine it from outside the container. The rest of the web service definition is the environment variables. As you can see, they are similar to the ones we defined on the .quartm file on our previous lesson, with some extra ones for the database user and password. Next, we'll define the Postgres database Docker instance. This file is pretty much self-explanatory. We will use the Postgres 13 Alpine image, instruct the container to always restart, put a name for it, and open port 5432 to the host, which is the standard Postgres port. Save the file. We won't start the Docker container yet, as we need a couple of more things in place.